In this video, we will be discussing about the other renewable energy sources, mainly the tidal energy, its source, and the type of power systems that is used to convert the tidal energy into useful energy. So the tidal energy we all know is a form of hydro energy recurring with every tide. So each and every tide has an amount of energy stored in it. So the periodic rise and fall of seawater water in a particular level, which are carried out by the action of sun and moon on water of the earth, is called a tide. So the rise and fall of tidal water is maximum near the seashore and river mouths. The tidal power, also called as tidal energy, is a form of hydropower that converts the energy tides into useful form of power, mainly electricity. So it is the only form of energy whose source is the moon. The basic principle of operation of the tidal cycle is the difference in water surface elevation at high tide and low tide. This differential head is utilized for operating a hydraulic turbine, which is coupled to a generator so that the tidal energy can be converted into electrical energy. The difference in potential energy during high tide and low tide is converted into tidal energy. So the tidal range of a tide is defined as the high full the tide is generally defined as the reaction of your moon and sun on the surface earth surface water. So the time variation in lunar month, so the tide we can see the tide height during new moon day and the full moon day is high than the quarter and third quarters tides. So they are known as spring tides and neap tides individually. So there are different types of tidal energy technologies that to extract the energy available in the tide. So the first one is your tidal barrages, and next one is your tidal stream generators. So the tidal barrage involves the creation of huge concrete dams with sluices. Sluices is nothing but a gate-like structure. The tidal barrage make use of the potential energy in the difference between high tides and low tides. Most of the existing tidal power plants use this type of design. Tidal stream generators make use of the kinetic energy of moving water to power turbines. Energy generation is very similar to the principle of wind power generation. Here, water flows across the blades, which turn turbine with much similar to how wind turbine blades are rotated using wind power turbines. So the tidal barrage system uses the height difference between the potential energy between the low tide and high tide, whereas the tidal stream generator uses the kinetic energy. Then next one is your dynamic tidal power system. So this technology is not currently commercial viable, but UK, Korea, and China have invested heavily in this research. It involves a partial dam which rises the tidal height, several hydropower generators. The difference in height between the head of the dam and low tide ghost force water through the generator, which is much similar to the traditional hydropower dam. So the different components of tidal barrage power plants are a main exponent of or component of any tidal power plant is the dam or barrage that is built across the mouth of a tidal estuary or inlet. This barrage is fitted with special slice gates that are opened and closed during the different stages of the tide. It is also fitted with hydraulic turbines that are coupled with the generators. The tidal energy is produced by trapping water at high tide into the barrage, and it is used to run the turbine when comes back from barrage during low tide. Therefore, the available energy in tide is proportional to the square of amplitude. skewed. So this is the diagram that shows the barrage system where the water is at high tide, and during low tide the water flows from high tidal basin to lower tidal basin, so which makes the rotor to rotate, and that is coupled to a turbine which is runs the generator and produces the electric output. So the main components are barrage or dam, sluiceways, embankments, and powerhouse. So there are different types of basin arrangements, which are single basin arrangement and double basin arrangement. So in single basin arrangement, the have only one basin interacting with sea. The sea and the basin are separated by a dam or dike that flow between them in through sluice gates located conveniently along the dike. The generation of power can be achieved in a single basin arrangement by either of the flowing system. So single ebb cycle system, single tide cycle system, and double tide cycle system. Single ebb cycle system is one as same as ebb generation. Similarly, the single tide cycle system is similar to flood generation as discussed in this earlier topics. Double tide cycle system is the two-way generation systems. So this is a single basin system where the sluice gates are opened and the dam is and the basin is filled through the upper sluice gate, and the lower sluice gate will be open and the rotor will be rotating, and the powerhouse through power in the powerhouse the generator is located and the electricity will be generated. So whereas in double basin scheme, a single basin plant cannot generate power continuously, though it can be used only for pumped storage plant. So there are two basins separately operate similar to the ebb generation cycle basin systems. The only difference is the proportion of the electricity is used to pump water into the second basin, allowing storage. A double basic scheme can provide power continuously and on demand, which is a great advantage. So it is a simplest double basin scheme. There must be a dam between each basin unseen, and also a dam between basins containing the powerhouse. With the two basins, one is filled at high tide and the other one is emptied at low tide. Turbines are placed between the two basins. This shows the double basin arrangement. Here we can see that there will be a sluice gate and two dikes and a powerhouse at the middle. The upper basin will be filled, and during the lower tide, the lower basin will be opened and the power flows up. Okay, water flows. Sorry. Next one is your tidal stream generator, which is known as non-barrage tidal power system. From the diagram, we can see that it looks similar to that of your windmill generator. So there are different models that has been used for your tidal steam generator. Here the water sea level inside the turbine is located under the sea level, and based on the tidal movement, the rotor will be rotated and the speed is controlled by a gearbox, and through tidal generator the electricity will be produced. So whereas the point observer, it will be floating on the up of on the sea level, and the based on the movement of your tide, the pump and generator will be flowed submerged heavily blast plate and mooring line, and it will be fixed dead weight through a dead weight at the bottom of your sea level. Whereas the linear observer, it looks like floating plate on the sea, and it is fixed through guidelines to the ocean flora. So as the movement of the up and lower tide will be extracted and the turbine rotates. So dolphin type wave power machine, which is similar to that of your wind power plant. Here the dolphin structure or the tower is fixed under the ocean wave, and at the top there is an absorbing generator, wave energy energy absorbing generator, and the connecting rod which float on the sea level moves up and down, which is converted into mechanical energy, and the generator converts the mechanical energy into your electrical energy. And the nodding duct, it is also called as Salter's duct. It is a large cam-shaped duct mounted on the long floating frame. Ducts oscillate and nod moves relative to the frame, which drives hydraulic pumps. Salter ducts rock up and down as a wave passes beneath it. This oscillating mechanical energy is converted into electrical energy. And the next one is your oscillating water column. So here the water column enters, there will be a chamber wall. The sea level, the water movement of the water enters the chamber wall and leaves the chamber wall during upper tide and lower tide, and the air in the water column will be pressured, will increase its pressure during the inlet of water, and the pressure is reduced during the outlet of water. Based on the pressure of the air column, the turbine is generator rotated, and that through that turbine generator is connected, which generates the electricity. This type of wind turbine generator used in an oscillating water column design is a key element to its conversion efficiency, which has its higher efficiency. So the air inside the chamber is constantly reversing direction with every up and down movement of the seawater, producing a sucking and blowing effect through the turbine. Therefore, the special type of turbine called Wells turbine is used. The Wells turbine has a remarkable property of rotating in the same direction regardless of the operation of airflow in the column. The kinetic energy is extracted from the reversing airflow by the Wells turbine and is used to drive an electrical induction generator. The speed of the airflow through the Wells turbine can be enhanced by making the cross-sectional area of the wave turbine duct much less than that of the sea column. Next one is a wave capture device, is also known as overtopping wave power device, is a seashore line to near shore wave energy device that captures the movement of the tide and the wave and converts it into potential energy. Wave energy is converted into potential energy by lifting the water up to a higher level. The overtopping wave energy converts works in much the same as the hydroelectric dam works. Seawater is captured and stored at a higher height above the sea level, creating a low head substitution, which is then drained out through the reaction turbine. Usually, the Kaplan turbine will be used. So, this is the sea overtopping device. The water is stored in the high level higher to the sea level, and through the water impoundment and the reservoir, the water through Kaplan turbine or turbo generator, the electricity will be generated. Thank you.